Alright, this video is for exam 1, page 9, section 6, and we'll be starting right now. Use squeeze theorem to prove the following limit. Limit of x approaching 0 from the right of root x times sine of 1 over x squared equals 0. So what we're first going to do is to write -1 less than or equal to sine of theta is less than or equal to 1. And we do this because sine of theta will be between the values of -1 and 1. We'll then plug in our theta, which in this case is going to be 1 over x squared. So 1 is less than or equal to sine of 1 over x squared less than or equal to 1. What we're then going to do is multiply by what we also have here. So we're going to multiply all sides by root x. So that'll leave us with negative root x less than or equal to sine, root x times sine of 1 over x squared is less than or equal to root x. And then finally we're going to be applying our limit, which in this case will be limit of x approaching 0 from the right of negative x root x less than or equal to limit of x approaching 0 from the right of root x times sine of 1 over x squared is less than or equal to limit of x approaching 0 from the right of root x. And then for our regular for the non-trig part of the equation, you will apply your limits. So in this case, negative root 0 is less than or equal to limit of x approaching 0 from the right of root x sine 1x is less than or equal to root 0. And then you just solve for these, which is going to be equal to 0 is less than or equal to limit of x approaching 0 from the right of root x times sine of 1 over x squared is less than or equal to 0. And as you can see, our value in the middle, limit of x approaching 0 from the right of root x times sine of 1 over x squared, is in between, is greater than 0, and also is greater than or equal to 0, and less than or equal to 0. And we are going to be using in squeeze theorem. It dictates that if your value is in between these two values that are greater than or equal to, then the only possible solution is that this entire equation must be equal to 0, because the only value that exists less than or equal to 0 between 0 and 0 is 0. And so we'll write that by squeeze theorem, limit of x approaching from the right of root that sine square is in between 0 from the left and right and therefore must be equal to 0. And that is all. And so we finish section 6, question 1. All right, and that is all. Bye.